Good evening. My name is Zach Lapana. I am the WSU Everett Engineering Club president. The club was founded back in 2014 at the end of the spring semester, so this is coming up to our 1-year anniversary. This is the first competition that our club is striving to attend. It's very exciting for us with that being such a large international competition. Our club is located at Washington State University's new branch campus, which is located on the Everett Community College campus. We share the University Center, which is on the Everett Community College campus, and a few of their other facilities. One of the facilities that we really partake a lot of effort and enjoyment in is the Advanced Manufacturing Lab. This lab is a 37,000 square foot warehouse that has welding, advanced manufacturing, machining, milling, carbon fiber and composite, repair, and new development. The mechanical engineering students take a class over there where they learn how to use the CNC mills and lathes. We have 3 N5-axis CNCs, manual lathes, and digital readout lathes. There's multiple 3D printers to allow us to do prototyping. A very large computer lab that has Mastercam and SolidWorks loaded on it, so students can take what they designed in SolidWorks, convert it to Mastercam, and get the G-code to go out and print it on the mills. With that being said, the club has been taking on this competition with a full sprint, full speed ahead mindset. The biggest thing that struck our attention, being mainly mechanical engineers, was the rugged terrain task. To meet the challenge competition, we came up with multiple chassis designs, starting with 6 wheels, 4 wheels, going through a rugged concept selection test. We were able to narrow it down to a four-wheel chassis with independent drive, skid steering, independent A-arms, and a frame rail design. This frame rail allows for optimal ground clearance, 8-inch tires, and a nice mount on the top for the robotic arm. The chassis also has a location to store tools for the field return task, and with that being said, the electrical engineers are working to make sure that the programming can read the GPS locations and we have proper video feedback. The robotic arm is also a portion of a capstone project for a few of the mechanical engineering students. With that being said, it's also been through several rigorous iterations of design and concept development and concept redesign. Our final design has linkage and a few other components that have been added in at the last minute to meet the realistic needs of motors that we can mount and to meet the weight limit. This arm was built and designed with a modular mindset, keeping that the manipulator at the end can be removed so we can add a soil sample drill with a humidity tester probe inserted into the center of it. The normal manipulator that has a 3-finger claw can open and close and rotate continuously, which allows for the turning of the gate valves and the ball valves. This manipulator is modular and able to be modified as needed. The EE students at our Everett campus are involved in this project, currently taking a course about embedded systems and programming, microcontrollers, so this is a perfect opportunity to exercise what they're learning in class and really get the hands-on experience more than just what they do in the lab. Right now, the mechanical engineering students just finished placing a large order with Protocase Manufacturing Incorporated, one of our great sponsors. They are supplying us with a few bolt-on items as well as a large amount of raw material that we will machine in our shop. The electrical engineering students are currently working on the mechanical electrical interface and the programming that goes with that. We're set to test near the end of April, and training will start right after we get done with the spring semester of May 9th. With that being said, it leaves us 2 weeks to dive in, work as a team to complete the tasks that we're going to need. Thankfully, we live in the Pacific Northwest where there's a large variety of diverse terrain from sand to rocks and everything in between, so we can get a good feel of how a rover will compete at the rover competition in Utah and how it would do on Mars. As to funding, we have adequate funds to complete our rover on time, thanks to our awesome sponsors Protocase, the Washington State University School of Engineering, and we also have other various sponsors, as well as our amazing website that our club members have invested time into to get just donations from anyone in general. With that being said, I want to thank you for entertaining and inviting Washington State University to compete with the CDR review. I want to thank you for your time, and we look forward to seeing you guys in Utah. Thank you.